In the last video we installed CoDeSys v3 on our Windows system. If you're wondering how to do that, or if you haven't seen the video, please check out the link in the description of this video. By the end of this video instead, we will have a running industrial control program executing logic on your computer. We are going to write the automation equivalent of hello world, compile it, and have it run on the simulation mode of CoDeSys. When you open CoDeSys, you should see something like this, or maybe a welcome screen in the center part of the screen. To create a new project in CoDeSys, you can select File and click on New Project. This will open up a list of templates that you can choose from, and choosing the standard project is often quite fine enough, since it provides the basic structure defined by the IEC 61113 standard, which gives us a device, a main program, and the task management for the PLC. Below here you can choose a name for your project and a location where the project file will be stored. After clicking OK, we get to a very important window. Here we can select our PLC, our hardware. This really doesn't matter if you are relying only on the simulation mode that is provided by CoDeSys, but if you want to run a different PLC, a physical hardware, or something that you have installed in your PLC environment in CoDeSys, you will see it right here. Typically, we can choose the control win v3, and choosing a different one will mean that you can go online and download on another kind of virtual PLC that is provided by CoDeSys on Windows. Then below you can choose in which language you want to create your main program of the project. For now, let's select structured text. We will also cover ladder logic later in this series, but structured text is the fastest way in which we can verify that our system is running correctly. Once you click OK, you will see on the left hand side that the device tree has popped up and has been filled with all sorts of stuff. It looks complicated, but it really is not. This device tree is your hierarchy. The device is your virtual PLC hardware. It can be a virtual PLC or a real PLC model, and if you double click on it, you can change all sorts of configurations related to your device. If you want to connect with a real physical PLC, here is where you will set the IP address or the communication settings to go online and download your code. PLC logic and application are just containers, and you cannot do very much with them. If you double click on them, nothing will open up. And the PLC logic holds the application, and the application holds everything related to the PLC code that you are working with. All the software that you are downloading is within the application, and the standard project will fill your application with some stuff that you almost always need. It creates for you a library manager in which you can manage the libraries that are preloaded by CoDeSys onto your system. You can add a new one, you can even create your own and add it later. It creates a task configuration in which you can configure tasks for the execution on your PLC. The task configuration will show you a recap of all the tasks that have been scheduled to run on your PLC. The standard project adds a single task called main task, and in the hierarchy you can see that it calls exactly the PLC_PRG program. By double-clicking the main task, you will see all the settings that are related to it. In the top part, you can see the priority. Lower value of priority means that is more important, and it will preempt less important tasks. You can set the type of task. You can choose between cyclic, so a task that is called at a certain interval, event, a task that is called when a specific event occurs, freewheeling, a task that will occupy all the available load of the CPU and run for as much as possible, and a task that is scheduled on a status change of a PLC variable. Most of PLC tasks are cyclic in all PLC applications, and if you select cyclic, you can set the interval at which the PLC task will run. The default for this task is 20 milliseconds. This means that all the programs that are scheduled within this task will be called every 20 milliseconds. Just below, you can enable a watchdog. A watchdog is a fail-safe mechanism that will send the PLC to an unrecoverable exception if the specified task will run longer than a certain amount of milliseconds. For instance, if I were to write 100 here, if this specific task runs for longer than 100 milliseconds, it will create an exception. The sensitivity means for how many times the system will allow the task to overcome this specified time. So for instance, if I write 5 over here, I will only get an exception if this task runs for more than 100 milliseconds for 5 times. Below 5 times, it will not generate an exception. This is typically a fail-safe mechanism for when a PLC task hangs or for some unknown reason it runs for longer than expected. Typically in PLCs you want to have control on the scheduling times and the running times of your task. Below you will see all the programs that are called by the specific task, and over here we have only one call to a program called PLC_PRG. This is the program that you can find in the device tree, and this is the main program that has been added by the standard project in CoDeSys. You are free to delete it or change its name, but this is what the standard project of CoDeSys loads. Now let's double click on this program in the devices tree. This is where we will write some logic. As all program organization unit, the PLC_PRG has two parts. The declaration part on the top, where we can write variables, and the implementation part at the bottom, where we can write code. If you wish to know more about program organization unit, or you wish to have a textbook by your side about PLC programming, check out PLC Programming for Beginners, my own book on Amazon. Check the link in the description if you are interested. Here we can declare a variable. Let's create an integer variable called counter. Just like this. The syntax to create a variable is name of variable, colon, type of variable, semicolon. This line means that our variable is named counter and it is an integer type. Just below, in the implementation part, we will write some structured text code. Just something simple for now. We want this counter to increase, so I will simply write counter colon equal counter plus 1 semicolon. This is the syntax in structured text for the assignment. We are assigning to counter its own value plus 1. This means that whenever this line of code is run, counter will increase by 1. The colon equal is the syntax in CoDeSys and in all structured text languages for assignment. Don't confuse it with a single equal. We have now written our first PLC program. Now we need to download it on a PLC and run it. but since we do not have a real PLC, we can enable CoDeSys simulation mode. To do that, we can simply click onto Online and select Simulation. After that, you will see on the bottom right part of your screen a red simulation popping up. This means that CoDeSys has enabled the simulation mode. If you skip this, CoDeSys will try to find a physical PLC to connect to, and if you do not have one, it will fail. Now let's compile our code. To do that, you simply go to the Build menu and click Generate Code. Once you do that, on the left side bottom part of the screen, you can open the Messages window, in which you will see errors, warning and messages related to your build. We have completed our build with no errors and no warnings. If you have some compilation errors, they will pop up there. Now we can go online with the login procedure. Note that if you don't compile and you try to log in, CoDeSys will automatically compile it for you. But it's important to know where the buttons are. So, to go online, you can either click on the gear with the green circle in the top bar, or go to Online, Login. This menu will pop up since you do not have a running application on your simulated system now. And since it does not exist, it asks you if you want to create it and proceed with the download. Click Yes. Right now, the application has been loaded onto the simulated PLC. As you can see in the bottom part of the screen, the CPU is in a stop mode, so the code is not running. To start running it, you can either click the play button on the top sidebar or go on to Debug Start. Right now, you can see that something is happening. In the code, you can monitor the online value of variables, and you can also do that in the declaration part over here. So we managed to create our first PLC program. Just another thing that is very important to know in CoDeSys, especially if you're running on a simulated system. If you want to change the value of variables on your own, you can force some values onto them. And to do that, you can go to the declaration part and write a prepared value over here. You can write, for instance, 0 to reset the counter to 0. And you can see that the value has not changed yet. We can see this prepared value also on the right part of the online monitoring of the set variable. To apply this value, you can either press Ctrl F7 or Ctrl F7 if you have the functions on Windows enabled, or you can go on to Debug and select Write Values. If you do that, the prepared value will go into the real value of the variable. This is how you can force to write variables from your own user interface in CoDeSys. Then, if you want to go offline, you can click this Logout button over there. Now let's make a simple modification to our program and try to download again and see what options CoDeSys provides us. If I change this to counter +2 and I press again the login button, CoDeSys will prompt me a different option. When we download an application that has been already loaded on a PLC and we have made some changes, we have three options. We can either log in with an online change. This means that the PLC will keep running and the code will just change from one cycle to the other, and it will change seamlessly and you do not need to stop the CPU. Instead, if you log in with download, the PLC will be stopped and all variables will be set to their initial values. Updating the boot application means that the application that will run when the PLC is turned on will be also updated. Or you can log in without any changes, so you will not download your changes. So I will log in with an online change, and you can see that it will seamlessly keep counting. If I log out and go back to counter +1 and then log in again, now doing a login with download, you can see that after that the PLC is in a stop mode again and counter has been reset to 0. And if I want to run it, I need to press back the start button. Great, we have created our first PLC program. Congratulations! Now you are ready to learn the actual languages and actual PLC programming. We are going to look at the theory behind what we just did, the IC 611313 standard, so you understand why the software is structured this way. Check out the links in the descriptions if you want more resources and more courses on PLC programming.